Hello friends, I welcome you in lecture number 3 on heat equation. In this lecture, we are going to discuss one question on heat equation which was asked in GTU Winter 2020 exam. Before solving this problem, we just recall what we have discussed in lecture number 2 on heat equation. We have seen that the solution of heat equation satisfying the boundary conditions that temperature is 0 at both the endpoints of the given bar and initial condition ux0 equal to fx. So solution of this initial boundary value problem is given by uxt equal to sigma n equal to 1 to infinity bn times sin n pi x over L e raised to minus lambda n square time t, where lambda n is given by c into n into pi divided by L, and this bn is the Fourier coefficient and its formula is 2 divided by L integral from 0 to L fx times sin n pi x by L integral with respect to x. And here this formula is applicable if boundary conditions are in such a way that value of temperature is 0 at both the ends of the given metal bar or given metal rod. So we are considering the problem in which the model is governed by heat equation satisfying this type of boundary condition and this initial condition. So first we understand what is given in this problem. A bar of length 2 meter is fully insulated along its sides or laterally insulated. This means the length of the bar is 2 meter and it is fully insulated along its sides. That means from this side as well as this side there is no heat flow allowed. Heat cannot pass through the sides of the bar. That is the meaning of this statement that bar is fully insulated along its sides. Sometimes they can use this word also, that bar is laterally insulated. So here length of the bar is 2 meter. That means value of capital L is 2 meter. It is initially at a uniform temperature of 10 degree Celsius and at T equal to 0, the ends of the bar are plugged into ice and maintained at a temperature of 0 degree Celsius. Here it is given that bar is initially at a uniform temperature of 10 degree Celsius. That is, initial condition is ux0 at T equal to 0, bar is having uniform temperature of 10 degree Celsius. That is, this fx is equal to 10 for every x satisfying 0 less than or equal to x less than or equal to 2. And at T equal to 0, the ends are plugged into ice and maintained at a temperature of 0 degree Celsius. This means temperature at both the ends is 0. U0T equal to 0 and U2T is also equal to 0. It is given that the ends are plugged into ice and maintained at a temperature of 0 degree Celsius. Determine an expression for the temperature at a point P which is at a distance x from one end at any subsequent time t seconds after t equal to 0. Here we have to determine an expression for the temperature at a point P. That means somewhere along the bar. Suppose this point is denoted by capital P. Then suppose coordinates of this point are x comma t. Then we have to determine an expression for the temperature at this point P, which is at a distance x from this end and at time t. So here we can see that in this problem, boundary conditions are given in such a way that temperature is 0 at both the ends, and initial condition is given by ux0 equal to 10 for every x along the bar. Now they have asked this question in this way in GTU Winter 2020 exam, and the same question they have asked in GTU Summer 2020 exam in this way, that find the solution of heat equation del u by del t equal to c square times del square u by del x square together with the initial and boundary conditions u0t equal to u2t equal to 0 for all t greater than or equal to 0 and ux0 equal to 10 for every x along the bar. So same question can be asked in different ways. Here they have written the same problem in descriptive way, and here they have written that find the solution of heat equation satisfying these two boundary conditions and this initial condition. Now once we understand the question, we have to find out the temperature distribution at any point x and at any point t. So this is the formula for the temperature distribution, in which we have to first find out value of Bn. So Bn we will find out using initial condition, and lambda n is Cn pi over L. So after finding Bn, we will substitute it in this expression, and we will be able to determine an expression for the temperature. So here first I am writing that here ux0 is equal to 10, and hence we have fx, value of function fx, which we will use in calculating Bn is 10. Fx equal to 10 for all t greater than or equal to for all x along the bar, for all x such that 0 less than or equal to x less than or equal to 2. Here length of the bar is 2 meter, that is capital L is 2. So first we find out value of Bn. Bn is given by 2 divided by L integral from 0 to L fx multiplied with sin n pi x over L integral with respect to x. Value of fx is 10 and L is 2. So I put L equal to 2 and fx equal to 10. 10 times sin n pi x over 2 integral with respect to x. These two will get cancelled, and 10 is independent of x, that we take outside, and integral of sin n pi x by 2 is minus cosine of n pi x over 2 divided by coefficient of x, which is n pi divided by 2, and limits of integration are from 0 to 2, that is we have to take x equal to 0 and x equal to 2. This I can rewrite as, if I take this n pi by 2 in the numerator, I can rewrite it as minus 2 divided by n pi. I am taking all these quantities which are independent of x outside the bracket, and cos n pi x divided by 2, limits of x are from 0 to 2, and this is minus 20 divided by n pi. First I will take x equal to 2. So if I take x equal to 2 here, these 2 will get cancelled, and I am left with cosine of n pi minus cosine of x equal to 0. And we know that cosine of n pi is nothing but minus 1 to the power n, and cos 0 is 1. And this we can rewrite as, if I take negative sign inside the bracket, I will have 1 minus minus 1 to the power n. This is the value of Bn, where n start with 1, 2, 3 and so on. Now due to this minus 1 to the power n, we know that minus 1 raised to n is 1. if n is even, and it is -1 if n is odd. So if n is even, this is going to be 1, and we have 1 minus 1 equal to 0. So Bn will be 0 if n is even number, and if n is odd, this is going to be -1 and minus minus plus. So I will have 2 here for n odd, and 2 into 20, that is 40. So this will become 40 divided by n pi if n is odd. So this I can rewrite as Bn equal to 40 divided by n pi if n is odd. If n is odd, then this is going to be 1 minus minus 1, that is 2 into 20, that is 40 divided by n pi, and Bn is 0 if n is even. So this is value of Bn, and n is natural number, so I have to specify n equal to 1, 2, 3 and so on. We have to write lambda n also. Lambda n is given by c times n times pi divided by l, that is c n pi divided by 2, and takes the values 1, 2, 3 and so on. And finally we can write down the distribution, temperature distribution. So the temperature at any point capital P on the bar, which is at a distance x and at time t, is uxt equal to, we have to remember this formula, easy to remember, sigma n equal to 1 to infinity Bn sin n pi x divided by L e to the power minus lambda n square times t, and this is equal to sigma n equal to 1 to infinity Bn sin n pi x divided by 2 e raised to lambda n is cn pi divided by 2. So here I write cn pi over 2 square of this quantity multiplied with t. This is the expression for temperature at any point x, t. Now Bn is 0 if n is even. So I can write down few terms. Suppose I write for B1, B3 and B5. Suppose I am writing for n equal to 1, then I will have B1 times sin pi x by 2 e raised to minus, if n is 1, here I will have c pi divided by 2 whole square into t, plus if I take n equal to 3, I will have B3 sin 3 pi x over 2 e raised to minus 3 into c into pi divided by 2 whole square into t. Similarly for n equal to 5, B5 sin 5 pi x divided by 2 e raised to minus 5 times c times pi divided by 2 whole square multiplied with t, and so on. Now B1 is from this expression. For n equal to 1, I will have B1 equal to 40 divided by 1 into pi. For B3 I will take n equal to 3, and I will have 40 divided by 3 into 5. B5 will be 40 divided by 5 into pi. So in every constant Bn, we can see that 40 over pi is common, and what is different is this 1 by n. So I can directly write 40 over pi by taking common. Suppose I am writing 40 over pi outside, then for b1 I am left with 1, and this term sin pi x by 2 and this term. So here I am writing sin pi x by 2, and if I square this I will have c square pi square t divided by 4 and negative sign. So here I am writing minus c square pi square into t divided by 4. Similarly for b3 is 40 over pi into 1 by 3. So here we are left with 1 by 3 sin 3 pi x by 2 minus e raised to 3 square c square pi square t divided by 4. So that also I am writing 1 divided by 3 sin 3 pi x over 2 e raised to minus 3 square c square pi square t divided by 4. Here I am taking square of this, that is 3 square c square pi square divided by 4 into t. And for b5 we will be left with 1 by 5 here. This is sin 5 pi x by 2 e raised to minus 5 square c square pi square t divided by 4 and so on. So this is the expression for uxt, and if we wish we can write in the form of sigma also. You can see here I can write 1 by 1, here I have 1 by 3, here I have 1 by 5. So in the denominator I have 1, 3, 5 like this. So this I can represent by 2n minus 1, n takes the values 1, 2, 3 and so on. That I can write here also. Here I have pi x by 2 into 1, here I have pi x by 2 into 3, pi x by 2 into 5. So that I can write as sine of 2n minus 1 pi x divided by 2. And same thing I can write for this. Here I have 1 square into c square pi square t by 4. Here I have 3 square into c square pi square t divided by 4. Here I have 5 square into this quantity. So here also I can write square of 2n minus 1. So in sigma notation our expression for temperature is uxt equal to 40 over pi outside summation 40 divided by pi sigma n equal to 1 to infinity, and first I have to write 1 over 2n minus 1. So 1 divided by 2n minus 1 sine of pi x by 2 into 2n minus 1, that is sine 2n minus 1 pi x divided by 2, and e to the power minus, here I have to write this quantity as it is, c square pi square t divided by 4 into square of 2n minus 1, that is c square pi square t divided by 4. So this is the solution of given heat equation satisfying given boundary and initial condition, or we can say that this is the required expression for the temperature at point P, which is at a distance x and at time t. So in this way we can easily solve this type of problem. All we have to remember is that this formula, that suppose heat equation is given with temperature 0 at the endpoints and initial condition ux0 equal to fx, then its solution is given by uxt equal to sigma bn sin n pi x over L e raised to minus lambda n square t, where lambda n is cn pi over L and bn is given by this formula. and it is easy to remember this solution, and they generally ask this type of problem for 7 marks in GTU exams. Sometimes they can ask in different way. Here we have seen that they have asked the problem by writing the description, and here they have asked the same question directly, that solve the heat equation together with this boundary and this initial condition. So all I have done is I have just obtained the value of Bn using integration and lambda n, and then I am substituting them in this expression for temperature distribution. So this is very easy, and we will be discussing some more problems of this type in upcoming lectures. Thanks for watching.